vertical field is proportional to the gate overdrive, it is not surprising that the gain value is multiplied by the following factor. So definitely because of all these degradation, you have to multiply the drain current by 1 by 1 plus theta into VGS minus VGT. Theta is the degradation factor. It is depends on 0.1 to 1 per volt. So it is device dependent, and it increases as your thickness is going to decrease. And the relation between theta and oxide layer thickness given by theta equal to 2 into 10 power minus 9 meter per volt divided by T ox. So these degradation can influence the real behavior of devices. So they will reduce threshold voltage, the drain current will reduce, the mobility will reduce. So it will bring down the required performance of your device. And finally, transit time effect. You know, transit time is time required for the electron to cross from one region to another region. So only when transit time is less, you know, the high frequency operation is possible. You know, F is equal to 1 by T, correct? So when the time period is less, high frequency operation is possible. So transit time is not a much concern in short channel device where the length of channel is very, very small, but it is of a great concern in the long channel device. So how much time the electrons takes to cross from source towards your drain. Okay, so if the length is large, you have a delay associated with that. You have a time delay because of transit time. And this time delay will unnecessarily bring non-linearity into your device. Instead of drain current ID becoming ID, instead of ID being proportional to VGS, you know ID is proportional to VGS, it will be proportional to VGS square. So when ID is proportional to VGS square, it becomes saturation. So saturation region will be invoked in your device. So transit time also plays a major role in the characteristics of your device. So transit time can be overcome by using short channel devices where the channel length is very, very small when compared to the time taken for the electrons to cross from source towards your drain. So today actually we have seen about completely about the small parameters in MOSFET. So till yesterday we have seen about the different regions of operation, but today we have seen about the MOSFET capacitance. So the two frequency figure of merit, high frequency figure of merit, and then we have seen the different important topics in designing MOSFET. One is weak inversion, short channel regime, and then threshold reduction, how it happens, substrate current, gate current, channel length modulation, back gate bias or body effect. Then we have seen about how temperature variation is going to affect your MOSFET performance. And then finally, we have seen how the mobility degradation is going to happen when you are going to apply the electric field across the device and the transit time effect. So this will complete the understanding of MOSFET device physics.